Yeah, you want to take it, Vikram?
No, go ahead. Go ahead.
Yeah, welcome to the last session of the day. We have Vikram and Chris here with us. And this talk, we'll be exploring the benefits of combining fault injection and load testing, which is two interesting combinations, to ensure the robustness of software systems. Presented by Vikram Raju, the program manager at Azure Chaos Studio, and Chris Ashton, principal software engineer at Microsoft. So yeah, we'll see how we can make our software systems more resilient, I guess. Yeah, take it away.
Thanks, Ayan. Let me just present the deck real quick. Testing. All right, there we go. So, hey everyone, my name is Vikram Raju. I'm a PM on the Azure Chaos Studio team. I'm here with Chris Ashton, one of our principal PMs. And today we're going to talk about resilience, chaos engineering, Azure Chaos Studio, and the use of fault injection and load testing techniques to build the resilience of your cloud application or service. We'll cover chaos engineering concepts, load testing, and outline how Azure Chaos Studio helps customers build application resilience. Now, I know you all are probably familiar with resilience in the cloud at this point, as we're at the Chaos Carnival conference and we're one of the last talks, but hopefully we can color this presentation with some Microsoft-specific chaos engineering attitudes and principles overall. So stay put, and hopefully by the end of this, you walk away with some valuable information. So what we're trying to emphasize here is that, as you know, the cloud abstracts away the management, maintenance, security, and more of physical infrastructure. PaaS services and microservice architecture simplify further and abstract away compute and networking layers, allowing rapid application development. While this has many benefits, there are also drawbacks. A new set of dependencies, lack of control, and lack of visibility. With your own data center, you had control over resolution of any outage. Whether or not resolution was faster than in the cloud, at least you could understand and control the outcome with more certainty than when you get a service health notification in Azure. Knowing this, we believe cloud solutions need to be more resilient than ever. We believe resilience is a shared responsibility, like security or privacy, across the cloud provider and the customer. Azure needs to meet and exceed our SLAs and SLOs and reduce incidents. SLAs are service level agreements, if you're unfamiliar with the term. Customers need to build resilience against Azure outages and design durable applications. If Azure were 100% available, but a code defect caused a customer application to go down, that 100% availability of the cloud is useless. The inverse is also true. Applications change over time as new features are deployed. The Azure platform and its foundational hardware, as well as each of your service dependencies, can change at any time. Microsoft provides the Azure Architecture Center and the well-architected framework guidance. Resilience needs to be built into the platform. Applications need to design and implement resilient solutions. To ensure standards are being met, resilience needs to be validated. Applications must be subjected to the issues they will face in production. This is where chaos engineering comes in for us. This is why we've built Azure Chaos Studio. Microsoft uses chaos internally to build resilience into our platforms, services, and applications. Teams like Microsoft Teams, Azure Active Directory, and Azure Key Vault have started to use Chaos Studio to improve their resilience. We want to empower customers to do the same. Now, I'm sure you've seen a version of this slide many times throughout this conference, but in my mind, it always helps to hammer in the point that chaos engineering is very important. As you can see here, outages in cloud infrastructure can cost companies millions of dollars. Even relatively short disruptions can have a large impact. Resilience is important because, simply put, outages in the cloud are inevitable. A lightning strike can cause a power outage, a data center can get flooded, and a certificate can expire. There are far, far too many examples to mention here. Every outage or issue in your service impacts availability, which in turn impacts your business. Beyond customers getting upset, we as a cloud provider understand there can be broader impact. Depending on the industry or workload, there can be financial, legal, regulatory, or even life or death consequences. Beyond downstream impact, within your organization, outages steal developer time. If developers spend all of their time debugging and resolving live-side issues, they are not building new features or products. In all organizations, and especially at Microsoft, we believe that quality practices can't just happen on one team, in one service, or in one environment. Quality needs to be embedded into the entire service development and operation lifecycle, just like security. So I'm not going to go too deep into the what is chaos engineering topic, considering where we all are, but hopefully I can give you all insight into Microsoft's perspective on the subject. We recommend using the scientific method when implementing chaos to ensure systematic results. Establish a hypothesis with specific expected outcomes, structure an experiment that has controls and variables, and analyze results to determine if your hypothesis was validated or invalidated, and then make improvements and rinse and repeat. Chaos is not a one-time activity. Resilience validation is never done. As the application changes, you'll want to rerun your hypothesis to avoid regressions. Even if your application isn't changing, the platform and your application's dependencies are, as are the conditions under which they are running. In SRE communities, chaos engineering is often described as most useful in production. Production is the best place to replicate real-world traffic and exact deployment environment and configuration. But the impact and blast radius is high, and there is potential impact to customers. Production validation does have its place, but we believe chaos engineering is useful for a spectrum of environments, and it's best to use it early in the release validation pipeline to catch defects early and prevent issues affecting customers. As you may know by now, this is called shift-left chaos engineering. We also believe that chaos engineering is more than testing. Chaos enables validation of architecture, code quality, configuration, observability, and people processes such as on-call duties. Chaos includes fault injection, load testing, API and security fuzzing, and much, much more. Chaos engineering in our product, Azure Chaos Studio, can be used in automation or performed manually by hand-in drill events and game days. The important thing is to systematically and regularly validate real-world scenarios. This can be done through ad hoc experiments, CI/CD automation, and drill events. The important thing to call out here is when you perform a drill event, you're not only testing your code, but also the process and the people involved in your org. As I briefly mentioned before, we've definitely heard the stance within SRE communities that chaos engineering is only useful in production. However, in our conversations with Microsoft Azure users, we've come to discover that that posture isn't useful for most companies. While it's true that the most accurate resilience test is one run in production, most of our customers are early on in their resilience journey, or have production workloads that are far too mission critical to risk injecting faults into them. We believe chaos engineering is useful for a spectrum of environments and use cases, loosely categorized into two buckets: shift right and shift left. As you can see here, some of the subcategories we think about are in the image. Now, what I'm sure you've all been eagerly waiting for, on to Azure Chaos Studio. Chaos Studio is a new Azure service that helps you measure, understand, improve, and maintain product resilience using chaos engineering and fault injection. Chaos Studio is where fault injection, workload execution, and coordinated experimentation come together to enable hypothesis-based scenario validation. We are a fully managed service aimed at building resilience in your Azure services. We enable infrastructure as code experiment deployment via Azure Resource Manager, as well as impact analysis and observability tools with Azure Monitor integration. Additionally, Chaos Studio has an expanding library of faults for common Azure service issues, enables real-world scenarios using orchestrated parallel and sequential fault injection, and even lets users roll back experiments and grant granular fault permissions with Azure Active Directory to safeguard against fault injection causing outages. Chaos Studio aims to help with resilience at all layers of your application stack, from resolving bugs in the code you've introduced to building resilience against underlying infrastructure issues in Azure. We've initially focused our investments on platform building, agent-based faults, and service direct faults. On the application level, you can leverage in-process fault injection to disrupt Azure SDK API calls and customer code. This feature specifically is in preview and is coming soon for the general audience. To inject faults into your Windows or Linux VMs, you can utilize our Chaos agent and enable targets for agent-based faults within our CLI or our Azure portal experience. To inject faults and cause disruptions in your Azure services, you can utilize our Service Direct fault library and enable targets as such. Chaos for Infrastructure is used by Microsoft internally to disrupt underlying Azure infrastructure and impact anything running on it. This method can have a very large blast radius. Experiments can combine individual faults of different types to build up to orchestrated scenarios that represent real-world validation scenarios. And a key call out here is that we enable tenant isolation for you as an Azure customer and blast radius control as at an Azure subscription level. As you can see here, our experiment component and fault library feed into our high-level Chaos resource provider, which enables users through our portal user interface as well as our command line interface. Our Chaos resource provider is what enables you to inject service direct and/or agent-based faults into your application code and surface infrastructure. A couple questions that you may ask yourself when using Chaos Studio are, what aspect of my service resilience would I like to validate? What are the possible outcomes? One option may be to bring over your subscription, your resources, your application, and then apply some load, or choose a fault or faults and target or multiple targets, start your experiment, and monitor what happens. At the core of Chaos Studio, as I mentioned before, is a Chaos experiment, which is an Azure resource. It allows you to orchestrate everything from simple single fault tests, like for example, failover a Cosmos DB instance, to complex experiments that involve several faults being injected in parallel and/or sequentially. A Chaos experiment is comprised of steps, branches, and actions. Steps, which run in sequence, consist of branches, which run in parallel. Actions live in branches and execute fault actions. Chaos experiments run faults on targets, which are just Azure resources that have been onboarded to Chaos Studio. The sophisticated orchestration in Chaos Studio allows you to replicate many real-world scenarios. Anything from a region outage that requires modifying network configurations to shutting down resources, failing over databases, and more. Another use case for complex experiments is recreating previous outages where a problem was the result of multiple compounding issues. As I briefly mentioned before, one option to test resilience in the Azure world is load testing, which you can do through our Azure load testing product. Azure load testing is a fully managed load testing service that enables you to generate high-scale load. The service simulates traffic for your applications regardless of where they're hosted. Developers, testers, and QA engineers can use it to optimize application performance, scalability, or capacity. You can quickly create a load test for your web application just by using a URL and without any prior knowledge of testing tools. ALT, Azure Load Testing, abstracts the complexity and infrastructure to run your load test at scale. For Azure-based applications, Azure Load Testing collects detailed resource metrics to help you identify performance bottlenecks across your Azure application components. You can automate regression testing by running load tests as part of your continuous integration and continuous deployment workflow, your CI/CD workflow. Azure load testing also enables you to test private application endpoints or even applications that you host on-prem. For more advanced load testing scenarios, you can create a load test by reusing an existing Apache JMeter test script, a popular open source load and performance tool. For example, your test plan might consist of multiple application requests, you want to call non-HTTP endpoints, or using input data and parameters that make the test more dynamic. So how does Azure load testing work? The test engine, as you see there, abstracts the required infrastructure for running a high-scale load test. The test engine runs the Apache JMeter script to simulate a large number of virtual users simultaneously accessing your application endpoints. When you create a load test based on a URL, Azure load testing automatically generates a JMeter test script for you. To scale out the load test, you can configure the number of test engines. Just as an FYI, the Azure load testing service uses Apache JMeter version 5.5 for running load tests. You can use the Apache JMeter plugins from the JMeter website or even upload your own plugin code. Azure load testing also supports all communication protocols that JMeter supports. For example, to load test a database or a message queue. Your application can also be hosted anywhere, in Azure, on-prem, or in other clouds. To load test services that have no public endpoint, you can deploy Azure load testing in a virtual network. During the load test, the service collects the following resource metrics and displays them in a dashboard. One metric is client-side, and these give you details reported by the test engine. They include the number of virtual users, the request response time, and the number of requests per second. The other metric type is service-side. These provide information about your Azure application components. ALT integrates with Azure Monitor, including application insights and container insights to capture details from these Azure services. Depending on the type of service, different metrics are available. For example, metrics can be used based on the number of database reads, the type of HTTP responses, or the container resource consumption. ALT also automatically incorporates best practices for Azure networking to help make sure that your tests run securely and reliably. Load tests are automatically stopped if application endpoints or Azure components start throttling requests. Also, data stored in your Azure load testing resource is automatically encrypted with keys managed by Microsoft. This data includes, for example, your Apache JMeter script, as I mentioned before. Now back to Chaos Studio, and more specifically, our fault library. Individual faults allow an array of disruptions and validations. Combined, they enable complex scenario validation. Each of these validation types has a place. Add systemic disruption of individual resources to integration tests in a test stage. Add scenario validation to a pre-production or canary environment. When you are confident and mature as a Chaos Studio customer, add scenario validation in prod. Some fault actions perform actual disruptions, like to kill a process, shut down a VM, or fail over a Cosmos DB instance. Other faults simulate disruption. Network security group rules can create a temporary network rule, a network port block, or simulate a noisy neighbor. So just some high-level insight into our product timeline here. We went into public preview in fall of 2020. We went into public preview in fall of 2021, and we're planning on becoming generally available this year in 2023. Also recently, we've added several faults, including a key vault deny access fault, an Azure cache for Redis reboot fault, among others, as well as many new features. Some of the things we're working on now are expanding our fault library even further, simplifying our identity and access management flow, making target resource filtering much more granular, and providing users a simple guided experience to ensure just 5 minutes to a successful experiment execution. We're also expanding into even more regions, and in the future, we plan on helping customers conduct their own BCDR drills using our product. So here are just some general steps teams have used to get started with Chaos. First, we recommend just playing around with the product and getting a feel for experiment creation and execution. Later on, you can expand into more complex scenarios like drill events and automation. So at this point, we'll do a quick walkthrough of what creating a sample experiment in Chaos Studio looks like, so the smaller details don't get lost in the awe of watching something live. And then we'll move on to a live hands-on demo. So step one would be to navigate to the Azure portal and just search for Chaos Studio in the main search bar. When you click on that, you'll enter our landing page and you'll see our experiments and targets menus on the left side of your window. If you click on experiments, you'll see all the experiments that are created under your selected subscriptions, and you can choose to add an experiment from here. You can also do the obvious things like manage experiments, delete experiments, and filter based on which subscriptions you want to see experiments under. So when you click on Add Experiment, you're going to be taken to our main experiment designer flow, which starts on our Basics tab. Here, you're going to fill out general information such as what subscription you'd like your chaos experiment to live in, what resource group, the name of your experiment, and the location. After you're done filling that out, you can go over to design an experiment. Just skip through a bit here. Okay. So now this is our main sort of experiment designer. And here you can see the terms that I mentioned before, where you start at a step, steps execute in sequence, and then within a step, you see a branch. You can add multiple branches, which will execute in parallel. And then at the bottommost rung, you see a fault or an action. You can click on that Add Fault button, and you'll be taken to another pane where you can select from our fault menu and select which resources you want to target with that fault. And just as an FYI, the target list will be filtered based on which fault you use. So if you choose a VM shutdown fault, you won't see the resources that doesn't apply to. So you won't see non-VMs in that list. So in this example, we're adding an AKS fault on the Azure Kubernetes service. And as you can see here, the main thing to notice is that you can specify the fault based on the duration, and you can also add in a JSON spec to specify further how you'd like the fault to be executed. So this is the target resources pane that I was talking about. Over here, you can also filter based on subscription, and you'll see the targets that apply to the fault that you selected. From there, you can select a target and choose to add it to your experiment. So for more complex and non-simple chaos experiments, you'll want to add branches and more steps. So over here is just a quick example of adding a second branch to your experiment. You can give it a unique name. So when you go back to see your experiment details, you know what's going on. So over here, we're adding a second branch, which is just going to be a Cosmos DB Fallover. And just as you saw before, we have parameters that you can specify the duration the fault goes on for. In this specific instance, you'll want to specify the read region of that Cosmos DB instance. And you can also choose to target which instance under your subscription you'd like to run the chaos experiment on. So after you're done with the experiment designer, you'll be taken to our review and create page, where you're going to see the basics information of your experiment, as well as what you filled out in the experiment designer tab. And from here, you'll be able to create your chaos experiment. So after you create your experiment, there is currently another step that you have to take to assign the experiment permissions on the resources that you're choosing to target. You'll see that in the live demo, but let's skip over it for now. So from here, the experiment that you created will be in that main experiments tab. And from that tab, you can just choose to open the experiment. Then you'll be taken to the experiments page where you can view the details of it and also start the experiment. And once you've executed the experiment multiple times, as you see there on the bottom of the slide, you'll see the execution history. So when was the experiment started? Did it fail? Did it succeed? And if you click on that details button on the bottom right, you can look more granularly into which step succeeded, which step failed, which branch succeeded and failed, and specific fault actions that may have succeeded and failed from there. And more detailed error messaging would also be included in that details page. So as you see here, it's just what I mentioned. You can click on the step level, the branch level, and even the fault level to see why your experiment may have failed, why it's stalling, things like that. So the last step here is our observability and sort of telemetry features, where you can see while your experiment is running and after it has run, what actually happened to the instances and the Azure resources that you choose to target. Did your experiment run as hypothesized, or did something different happen? As you see there on the example on the bottom right, if you open up the Cosmos DB instance, you can see if the experiment had an effect that it was intended to have. So we'll skip the FAQ for now, and we'll move forward with the live demo. So let me share my Azure portal window. Just bear with me here. Okay, so this is what the Chaos Studio landing page looks like. The search bar that I mentioned before is just up here. Chaos Studio probably won't be one of the services on this top bar if you don't use it often. So you could just come over here, search for Chaos, and click on Chaos Studio from here. On this main page, we have quick links to our documentation and just shortcuts to reach these tabs where you can onboard resources on the Targets tab, and you can also create an experiment on the Experiments tab. So one thing I didn't cover in that experiment demo was actual target enablement. So once the Targets page loads, we can show you that you can see all the targets that are under your selected subscriptions, and you can also see if they're enabled for a certain type of fault. So I mentioned before, our fault types are split into service direct and agent-based faults. So under these filters, you can see, have I enabled these targets? Are they disabled? Does agent-based faults not apply to these targets? As well as other information such as subscription, resource group, as well as just the names of those targets. So say I wanted to disable this first target here. It's already enabled for service direct faults. All I would do is click on it and click on this disable targets button up here, and that target would be disabled. If I scroll down to a target that isn't enabled, again in the service direct fault example, I can click on it, choose to enable targets. As you see here, enablement for agent-based faults isn't applicable, so that's grayed out. And if I wanted to enable for service direct faults, I could click right here. Okay. Now we can move on to our experiments page. So over here, you see all the experiments that are in the subscriptions that have been selected. You can use these filters to filter based on subscription, resource group, location, and more. You can also see the status of your past experiments. Was the last execution successful? Did it fail? Did you never run this experiment? And more. So from here, we'll choose to create an experiment, and we'll be confronted with the Basics tab that I mentioned before. So pretty standard, as I mentioned before, just general information about your subscription, resource group, name, and region. So we can call this Carnival, have it live in East US, and move on to the experiment designer. So as I mentioned before, you can change your step names. We can call this step for Carnival. We can, not include a space there. We can also change the branch names. So we can call this Carnival branch. And we can choose to add an action. And in this case, we're going to add a fault. So over here, you can see our entire fault menu. And we have quick little tooltips that explain what each fault does. So you don't have to run back to the documentation and read through it to sort of get an idea of what these things do. So from here, we're going to go down to the VM shutdown fault, and we're going to leave the duration at 10 minutes. We don't want it to be an abrupt shutdown, and we're going to choose to target resources. So from here, you can also filter down your resources based on your subscription. And as I mentioned before, what you're going to see here is just VMs, since with the VM shutdown fault, other types of resources would not apply. So let's select this VR chaos trial VM, add it to our experiment. And as you see here, we have our fault details where we can see that we're applying a VM shutdown. It's going to be running for 10 minutes. We don't want it to be an abrupt shutdown, and we're targeting one resource. So from here, I can choose to add more steps and more branches to the experiment. But for the sake of simplicity and time, let's move on to the review and create page. So on this page, you'll see that you chose to have your experiment in a certain subscription, resource group. This is the name you gave it, and this is the region that it's going to live in. As we move down, you can see the details from the experiment designer. the name of your step, the name of your branch, as well as the fault you chose to apply. And from here, if everything looks good, you can choose to create your experiment. One quick little call up there before we do that. As you see here, it says before starting your experiment, you'll need to assign the experiment identity to each resource targeted. What this is basically saying is your chaos experiment needs permissions to run these faults on the resources that you added to the experiment. So in this Learn More link, it'll take you to a link to our documentation where you can run through the steps to do that, but I'll also be doing it here after we create the experiment. So we hit create. The experiment is pretty simple, so it shouldn't take too long to deploy, but it may take a minute or two. Just be patient, and there we go. Your deployment is complete, and we can go to the resource group that it lives in, or we can just go back to Chaos Studio and find the experiment here. As you see here, Carnival, perfect. So in terms of permissions assignment, let's start back at the Azure portal. For this specific experiment, we chose to target a virtual machine. So the first step in permissions assignment is to go to the actual resources, in this case, in the Azure portal that you're running your faults or actions on. So let's go to virtual machines. Let's find the virtual machine that we chose to target. In this case, it's VR Chaos Trial. We then go to access control. We choose to add a role assignment. And then we choose the role that we're going to add to the experiment. So for example, if we want to add a reader role, we select the reader role. But in this case, we want to add an owner role. I already have this done. This might take a little bit of time. It's kind of confusing if you're creating a chaos experiment for the first time. But basically, once you add the role, you're going to want to go back to your chaos experiment. And I have another just completely the same chaos experiment that has that role added. If we go into the details of this experiment, we can see that it's the exact same VM shutdown on that exact resource. Okay. And we can choose to start the experiment from here. This might take a little bit. I did do a successful experiment execution of this experiment in the past. So just for time's sake, let's go into that successful execution and view the details. So as I mentioned before, you can look at your experiment execution details on a step, branch, and action level. And the status for each one will be indicated as you see here. We can also click on the action level, and if there isn't any error message, this screen isn't as helpful, but if the action fails to run, there will be an error message indicating why. In a lot of cases, it will be because of failed permissions assignment or other sort of details related to the experiment not having sufficient permissions. So you'll definitely want to be sure to complete that step. Okay. So now let's move on to playing around with Azure load testing. So similar to Chaos Studio, you can find Azure load testing just by searching for it on the search bar. And what you're going to want to do to start out is create an Azure load testing instance. Over here, it's very similar to Chaos Studio in that you'll select your subscription, your resource group, the name, and the region of your load testing resource. For the sake of time, I won't actually enter in all that information, but as you can see here, you can also choose the types of managed keys you want Microsoft or yourself to use for the experiment to encrypt your data. And then if we move on to tags, you can add any Azure tags to the load testing resource. And then finally, the review and create page will be the same as it was in Chaos Studio, where you can just see the different information added to your load testing resource and choose to go back and modify it as you wish. If we go back to the main load testing page, I have created a load testing resource, which we can play around with. So as I mentioned before, you can run a quick load test very easily by just entering in a URL of the website that you want to test load on. Since we're going to just demo out this functionality, let's choose to run it on azure.microsoft.com. This isn't actually going to affect the Azure website, but just for the sake of example, let's go ahead, enter that in. You can select the number of virtual users you want to simulate in regards to this load, as well as specify your test duration, as well as the ramp up time of the actual load that you're injecting onto your website. So from here, we can hit run test. Since it's a dummy URL, there isn't actually going to be any load applied on the system. But if you were to enter in an actual URL, you could see your load test results as well as your engine health while the load test was going on over here. So let me go ahead, stop sharing that, get back to the presentation. Okay. So from here, we'd like to open it up to any questions you all may have on Chaos Studio, load testing, or anything that was mentioned in the presentation. Also, feel free, if questions don't come to mind right now, you can ping me and Chris. We can put our emails in the chat window. And if anything comes to mind later, you can definitely email us.
Sure. Awesome talk. I think it's really insightful. A lot of questions on Azure, a lot of insights today from Chaos Studio. So I see a few questions. Some of them are getting a lot of attention as well. So I'll just pin a few on stage, and then you can answer quickly, and then we can move on to the last closing session. So
Yeah,
yeah,
sure.
do you have any plans for Litmus Chaos as one of the popular projects, or any other, let's say, project integrating into Azure Chaos Studio?
Yeah, sure. Chris, do you have any insight into this?
Oh, there we go. I typed to the chat window. We've considered this. It's a semi-common request. We don't have a timeline to deliver that anytime soon, but it's one of the things. And I pasted a link in there where you could upvote requests like that, and that will help us prioritize that work as we in the future.
Got it. Makes sense. Cool. Let's move on to the second one real quick. So yeah, what are the major barriers that Chaos Studio faces in terms of adoption?
Yeah, so one of the barriers that I mentioned before was just with our identity and access management flow, which we're actively working on improving. And it's one of the next features that should roll out into Chaos Studio. And hopefully then users can have a much easier time with experiment, creation, and execution, as we're aiming to put as much of the permissions assignment and identity management flow that makes sense just in the background so users don't have to worry about it.
Right, makes sense. Cool. I think, yeah, due to the interest of time, that's all the questions we can take right now. But yeah, thank you so much for the talk. It was very insightful, and a lot of amazing steps that people can follow and try Chaos Studio as well. So yeah, thank you so much for the talk.
Awesome. Thanks for having us.
Thank you. We'll be moving on to the closing session soon. So thank you guys for joining, and thank you guys for attending day 2 of Chaos Carnival. Bye.